Welcome to Aurora Chemistry for everyone. In this video, we go to analyze crystal field splitting in octahedral coordination entity. First, let us see what is crystal field theory. Crystal field theory is an electrostatic model which considers metal ligand bond to be ionic, arising purely from electrostatic interactions between metal ion and the ligand. It means metal ion is considered as electron deficient species, whereas ligand is considered as electron rich species. Here ligand also treated as point charges in case of anion or point dipole in case of neutral molecules. There are 5 d orbitals: dxy, dxz, dyz, dx squared minus y squared and dz squared. In that dxy, dxz and dyz, these orbitals lie between the axes. You can see here that axis, so they are lying between the axes. But for dx squared minus y squared and dz squared, this means these two orbitals lies along the axis. Look at this picture here. In octahedral coordination entity, there are 6 ligands. So these 6 ligands surround the metal atom or ion. So due to that, there is a repulsion between the metal d orbital's electron and the electrons which is present in the ligands. This repulsion is more when the metal d orbital is directed towards the ligand than it is away from the ligand. You can see here dx squared minus y squared and dz square. These both of them are directed towards the ligand. The remaining all are between the axes. So that is why these two orbitals experience more repulsions. So when they experience more repulsion, the energy becomes more. So that let us show that 5 d orbitals. This we can show it like energy. So there are 5 d orbitals: d, x, y, d, x, z. So these orbitals' energy is increased when they are surrounded by ligands. So the energy, increased energy, we will show. So average energy of the d orbitals in spherical crystal field. Why we call them as a spherical crystal field? If we are connecting all together, we will get the spherical field. So average energy. This average energy due to repulsion, what will happen to that? They will split. Now split into 2 sets. So this one is barycenter. This is a barycenter. Here that energy is constant. Now due to repulsion, we will get 2 sets of orbitals. Which one will be getting higher energy and which one will be getting lower energy? For that, you should know that these 3 orbitals lies between the axis, so the energy is less, but these 2 orbitals lies along the axis, so that is why the repulsion is more. So due to that, the energy of Eg orbital, this T2G orbitals, triply generated orbitals, this one is Eg orbitals, doubly degenerate orbitals. So now these Eg orbitals get more energy, then here triply degenerate orbital gets less energy. So how many orbitals here down? 3 orbitals. 1, 2, 3, T, 2G. Okay, so here G stands for symmetrical. So this is a symmetrical, octahedral is a symmetrical geometry. So we are using that T2G and EG orbitals. So this energy difference we called delta O. So O stands for octahedral field. So there is a gap between this energy difference. The reason is because of the difference in electrostatic field exerted by the ligands on T2G set of orbitals and Eg orbital and also metal ions. So here for Eg orbitals, what are the considered Eg orbital? dz squared and dx squared minus y squared. And for T2G orbitals, dxy, dxz and dyz orbital. So the energy of that 2 Eg set of orbitals will increase by plus 3 by 5. Why 5? Because there are 5 orbitals, d orbitals. Y plus 3, it is increased when compared to these 3 T2G orbitals. So we are writing plus 3 by 5. Then for T2G orbitals, it is decreased by, so we write minus 2 by 5. Thanks for watching.